Welcome to my maths tutorial. Today I'm going to do a related rates problem. The problem is, a balloon is rising at a constant speed of 2 meters per second. A boy is cycling along a straight road at a speed of 5 meters per second. When he passes under the balloon, it is 50 meters above him. How fast is the distance between the boy and the balloon increasing? 3 seconds later. Okay, so we know the time. 3 seconds. Here I've already made a diagram showing the balloon, the boy cycling along a straight line, and at that point, as he reaches the balloon, there's a 50-meter difference, and he's traveling along the road for 5 meters, for 3 seconds. Excuse me. So. We can here see that it's a triangle, and what we want to do now is find out how much the distance is actually increasing. So what we need to know for this is that the boy is traveling for 3 seconds, and we know the speed of the boy, which is 5 meters per second. So after 3 seconds, it will be 50 meters, which, excuse me, I made a mistake, I wrote 5 meters, is 50 meters. So 3 times 5 is equal to 15. And then here we have the 50 meters as he passes. But because we want to know what the distance is at that second, 3 seconds later, we have to find out our new y. And here you can see changes, and our new y is equal to, it rises 2 meters per second. So it's 15 plus 3 times 2 t and the rate, which is equal to 21 meters, as you can see here. This will be 21 meters. So from Pythagoras, we know that z squared is equal to a squared plus b squared. And in this case, we can say z squared is equal to y squared plus b squared. So what we don't know is the z under these conditions. So what we can do is find out the z first before we continue with actually finding our rate. So the z squared is equal to 21 squared plus the 15, excuse me, it's x, the 15 squared. And to actually just find out the z, we're just going to take the squared away and set this under the root, which will give us z is equal to 3 under the root of 74 in this case. So what we want to do now though is we actually want to find the rate that it changes in. So we're just going to take the derivative of it, because as you can see here, 2 meters per second, this is the derivative of the height that it rises. So we want to find out distance, and the distance in this case is z, which changes constantly, and this distance doesn't really change, so it is a constant. I'm sorry, it's not a constant, it does change. But I mean in terms of understanding what it's about, we want to find out that distance. And that distance will be taking this equation again and taking the derivative of it will give you, not to forget actually implicit derivative, will give you 2z, and then dz dt. I prefer using, instead of doing dz dt, I prefer just writing z dash. I'm going to change it afterwards, it's just easier for me to write. So it's 2z z dash equal to 2y y dash plus 2x x dash. So as we want to just know the derivative, we're just going to take z dash is equal to 2y y dash plus 2x x dash over the 2z. Now it's very simple. Now we just have to plug in the numbers, which in this case are z dash is equal to, we have the 2 times 15, which gives us 30, and then we have the derivative of it, the rate, which is 2 meters per second, so times 2, and then plus 2 times x, 2 times 15, which is, I'm so sorry, I wrote 2y is 30, it's confused. It's 2 times 21, which is 42, and then here's the 15, which is 2 times 15 gives us 30, times the rate of the x,